All right, we're dealing with a integral function here. For number one, g is a piecewise linear function defined from negative 2 pi to 4 pi over here, and whose graph is given above. And then this function f of x is g of x minus cosine of x over 2. Part A, find the integral from negative 2 pi to 4 pi of f of x dx. So, okay, in A, if we want the integral from negative 2 pi to 4 pi of f of x, we're looking for, I'm just going to take what f of x is defined as, and that's the integral from negative 2 pi to 4 pi of g of x minus cosine of x over 2. We can use the properties of integrals just to separate that difference, and that's the integral from negative 2 pi to 4 pi of g of x minus the integral from negative 2 pi to 4 pi of cosine x over 2 dx for both of those. Okay, this first one, this part right here, that we can just read from the graph. We are looking for the area, quote, under the curve of g from negative 2 pi to 4 pi. We're looking at a triangle here that has a base of, let's see, from negative 2 pi to 4 pi, that is a span of 6 pi, and then the height is 2 pi that we can see there. The area is, let's see, can I get a little bit of space? Ooh. Let's get a little bit of space. That's going to be 1/2 base times height. 1/2 base 6 pi times height 2 pi. We are looking at 6 pi squared for that part. Now the second piece of the expanded integral, the integral from negative 2 pi to 4 pi of cosine x over 2 dx, that is a little tougher. In fact, we don't have a nice handy interval that's memorized. We're going to have to use u substitution. Here's my side work. I'll label it SW here. To find the integral, let's let u equals x over 2. So du equals 1/2 dx. Then I'm going to rearrange that a little. 2 du equals dx. So I'm still with the side work here. I'm going to work for the integral from negative 2 pi. Oh man, no, I'm going to let's see, I need to change those integrands, right? I'm just going to keep them, I'm going to keep them as boxes for now. And I'm not going to make it in terms of u. I'm going to bring it back to x pretty soon. That's going to be integral of cosine of u and then times 2 du. So I'm just going to, that means I'm looking for the integral from, not quite sure yet, but I'm going to bring that 2 out. There's a minus sign here, and it's cosine u du. That is, let's see, the integral of cosine u means the function who has a derivative of cosine, and that's got to be sine. So that's minus 2 sine u from something to something. I'll clean this up, I promise. Now that's negative 2 sine x over 2, and I'm going to go back to the limits of integration from 2 pi to 4 pi. Okay, let me clean this up. Let's see if I can what we did here after u substitution, this part is 6 pi squared minus 2 sine x over 2. I'm going to evaluate that from 2 pi to 4 pi. I'm going to clean this up a little bit. Sorry, I'm working on my old iPad back home, which doesn't have space, and it's got a little tougher pen here. Okay, I'm going to work on this part, which is just evaluating the integral. So that's, here I'll write it again, 6 pi squared minus, okay, I'm going to put in the upper integral, that's 2, or the upper limit of integration, 2 sine 4 pi over 2 minus 2 sine 2 pi over 2. We'll clean that up again. Okay, that's 6 pi squared minus, this is going to be 2 pi. 2 sine 2 pi minus 2 sine pi. Wherever you are in your unit circle memory, maybe it's on the unit circle here, so we're looking at either 0 or pi, or 2 pi. That's 1 comma 0, or negative 1 comma 0, or if you prefer to think of the sign in terms of the graph of it, the sign of pi is 0. So 2 sine of the pi is 0. The sign of 2 pi, the sign of pi, that is over here, that's 0. 2 pi is one time around the unit circle, or at the very end of the first period of an unchanged sine curve, that's also 0. Our answer, 6 pi squared. Whoo! That, man, u substitution, integration, and trig. My goodness. Okay, I'm going to clean that up a little bit. That's part A. I promise that is probably that's the toughest piece right there, which is that integration. Part B says find all x values in the open interval for which f has a critical point. So critical points. What's going on? Critical points. A critical point is where the derivative is 0 or undefined. Okay, the derivative is 0 or undefined. So let's find f prime of x. I'm going to take the derivative of f prime, that is g prime of x, plus, now I take the derivative of negative cosine x over 2. This is going to use the chain rule. I take the derivative of the outside leaving the inside unchanged, so that's derivative of cosine, that's negative sine, so that means it's plus sine of x over 2 times the derivative of the inside, that's a 1/2. So I need g prime of x plus 1/2 sine x over 2. Okay, here's a tough part. When we want to find the derivative of g, it is not a constant function. It changes. In fact, it's got 2 linear components, so we have to kind of define it piecewise. So that means f prime of x is, it could be one of 2 things. G prime of x could be this first domain from negative 2 pi to 2, and the slope of that is just 1. So that's 1 plus 1/2 sine x over 2, and that is from negative 2 pi to 0. Or this other part where the slope is different, that is, let's see, rise over run, that's 2 pi over 4 pi, that's 1/2, negative 1/2, because it's sloping down, negative 1/2 plus 1/2 sine x over 2. And that is from 0 to 4 pi. That's a tough piece. So now we want to find out, we found the derivative. So I'll circle it here in green. That is the derivative. It's not an easy one-liner. In fact, it is piecewise defined. But once we found the derivative, we set it equal to 0, and we find critical points. And that is where the function, it has first derivative 0 or undefined. Let's take a look at this first element. 1 plus 1/2 sine x over 2 equals 0. I'm going to unwrap that a little, subtract 1, so that's 1/2 sine x over 2 equals -1. Multiply by 2, also known as divide by 1/2. That means the sine of something, x over 2, equals -2. That will never happen. There is no input into the sine function where the output is -2. So that is no solution for this part. For the second part, I'm going to put a check there because I've got that done. -1/2 plus 1/2 sine x over 2 equals 0. I'm going to unwrap it and divide by 1/2. Double check, but I get sine of x over 2 equals 1. So that means I'm going to take the inverse sine of both sides. That means I get x over 2 equals the inverse sine, the value, what angle has a sine of 1? That is pi over 2, because it has 0, comma, for the cosine 1. So that is pi over 2 plus 2 pi n. Whoa, a little pre-calculus here, where n is an element of the integers. We should say n is an element of the integers. And then I want to get x by itself. I'm going to multiply by 2 on both sides. X equals pi plus 4 pi n. So my principal, or my first answer there, is pi. And then every 4 pi before or after that are going to generate answers. My domain is only from 0 to 4 pi, not including 4 pi. So my one answer is going to be pi. That is the place that has a critical point, also known as what makes the derivative 0. Now there is one more place where a critical point could exist, and that is where it is undefined. The derivative is undefined, and that is at 0. So also x equals 0, where this function does not have a value. Okay, man, that was part B. All right, I'm going to clean this up. Do I have some space? Yeah, I got some space. Part C is let h of x be an integral from 0 to 3x gt dt. Find h prime of -pi over 3. I'm going to rewrite that again. Let's see, I'll change color. This is tough stuff. This is calculus stuff. Wow. H of x is the integral from 0 to 3x g of t dt. And we want to find h prime of something. Okay, so I'm just going to follow the rules here and take the derivative of h prime of x. And when I take the derivative of an integral, I just get that function in the integrand with the upper limit. So I'm looking at, oh no, I'm going to say, I don't know what that is. I'm going to call it h of 3x minus big H of 0 where h prime of x equals g of x. I'm just defining a new antiderivative. So h prime of, okay, sorry, I need to back up here. I'm just going to say h of x. I'm going to just rewrite this function as, now using the fundamental theorem of calculus, a difference of antiderivatives. Now, if I take the derivative of h of x, I'm going to take, that's h prime of 3x minus h prime of 0. And that means h prime of 0 is the slope of the tangent line at a constant function. That's just going to be 0. What happens in the first part of the sum is that h prime of 3x, that means I'm looking at going to use chain rule here. It's going to be g of 3x times the derivative of the inside, 3. Now, if I'm looking for, wow, now I need to go back and see what my input is. So I want h prime of negative pi over 3, means I'm looking for g of 3 times negative pi over 3 times 3. That means I'm looking for g of negative pi times 3. To get g of negative pi, I need to go up to the graph, and that is, negative pi is here. It looks like that output is 1. 1 times, oh wait, no, sorry, not 1. It is pi, so it's pi. When negative pi is the input, pi is the output, it is pi. So that is pi times 3, or 3 pi.